Next section has to do with what we call rational expressions. Right? When we speak of a rational expression in algebra, we're referring to what we call the quotient, which means the division. You're dividing two polynomial expressions. Right? So what I have here is polynomial expressions on the left-hand side. The polynomial expression would be something like 3x. We call that a monomial. 5x minus 4 is a binomial. X squared minus 6x plus 7 is a trinomial, and 2x squared plus 11 is a binomial. Right? These are called polynomials. Well, when we take two polynomial expressions and divide them, what you get are what are called rational expressions. So what I did is I took 3x and x squared minus 6x plus 7 and divided them. By showing this division process, you are actually creating what's called a rational expression. And likewise, I took 5x minus 4, a polynomial, and divided it by a 2x squared plus 11, another polynomial, and I get another rational expression. Now, remember, with division, it does matter how you divide. So if I flip this and put x squared minus 6x plus 7 in the numerator and 3x in the denominator, that's a totally different rational expression. So we do have to be careful how we divide. Make sure it's what we want here. All right, so with that in mind, when you create rational expressions, there's things we can do to simplify them, right? Make them simpler, just like there are for certain polynomials. We can combine like terms and make them simpler. With rational expressions, it's a little bit more involved, but the idea is still based upon what you would do with polynomials, or what we have been doing with polynomials, and that is factoring them. Okay, now keep in mind, constants are monomials. So we could throw in some other things like, say, 7 is a monomial. It's just called a constant. 5 is also considered a monomial. It's a constant. And if I were to take those two and divide it, 7/5, you think of that as just, hey, that's just a normal fraction. Well, that is a rational expression. And likewise, we can even go as far as to say, well, 1 itself is a monomial. It is a constant, so I could take any of these polynomials and divide it by 1 and still get a rational expression. In other words, if I wrote 3x over 1, now we wouldn't write it this way. We would simplify this to just plain old 3x. 3x itself, even though it's qualified as a polynomial expression, it is still considered a rational expression because we can, like I said, write it over 1 and call it a rational expression. So we can make a statement here that all polynomial expressions are considered rational expressions. However, when we talk about simplifying rational expressions, we're generally not talking a simple polynomial, right? We're generally looking at something like this. It's a little bit more formidable, but keep in mind, these are also rational expressions by default. Okay, well, with that in mind, we can simplify those, and we're just going to take a page out of our, grade school mathematics when we would simplify just basic fractions like this. Well, this is a rational expression, and we would simplify this. Now, the way you do it now might be a little bit different how I'm going to show it, but the quickest way, the best way, is to always look for the greatest common factor. The greatest common factor of 48 and 36, I believe, is 12. So we can write each part of this fraction, the numerator and denominator, as 12 times something. Right? So 12 is the greatest common factor. So I would write 48 as 12 multiplied by 4. That's 48. And then 12 times 3 is 36. Now, writing it this way allows us to cancel the greatest common factor, which is 12x in this case. Or we could just cancel common factors as well. I mean, if we would have said, okay, well, 2 goes into both of those and make this 24 over 18, but you'd have to keep going. That's why I chose the GCF. It can be done in one move. So canceling out the 12s, because those are a common factor, and this is going to be the whole idea of how we're going to simplify these rational expressions. We're going to cancel common factors. But the idea behind factors is you better be talking about multiplication, not addition or subtraction. So in this case, when the 12s cancel, you get the fraction 4/3, and you have simplified this fraction 48/36 into 4/3. They're the same expression, but this is considered simplified. Right? Now we do the same thing for all the other rational expressions. It's just sometimes we get a little confused as what we're calling factors. Okay? So if we look at this next one, what we could do is do the same exact thing as we did up here, looking for the GCF of both these terms. Right? That's definitely a way to do this. So the greatest common factor for both of these, well, let's start with 25 and 15. The greatest common factor would be what? 5 for both of those. Right. And then if you have 4 factors of x and 1 factor of x, the most they have in common would be just 1 factor of x. 3 factors of y, 7 factors of y, the most in common would be 3 factors of y. So what we're doing, we're just thinking what the greatest common factor of both of these are, just like we did a simple 12 up here. Now it's a little bit more involved with variables, but this is our GCF. That's actually what's going to cancel both numerator and denominator here. We just have to figure out, okay, what's left over. What do we have to multiply our GCF by to get the original? So up here we said, well, it's 12 times 4. That's 48. Well, 5xy cubed times what gives us 25x to the 4th y cubed? The answer is, well, 5 times 5 is 25, and we're going to need an x to the 3rd. Right, so 5x to the 3rd times 5xy cubed, that will be 25x to the 4th y to the 3rd. Do the same for the denominator. We'll need a 3. The x is covered. Y to the 4th. We'll cancel out our common factor, or in this case our greatest common factor, numerator, denominator, and what we're left with should be our answer. That's 5x cubed over 3y to the 4th. Okay, now doing it this way, it was a little bit more than what we needed to do. How I usually simplify these when it's a monomial divided by a monomial. Keep that in mind. A monomial divided by a monomial. I simply just go through, change colors here. I just go through it part by part. Largest number that divides into 25 and 15, the greatest common factor, is 5, still the same. 5 divides in there 5 times, into there 3 times. Right? Well, if I have 4 factors of x in the numerator and 1 factor of x in the denominator, only 1 factor of x is canceling both numerator and denominator, leaving me with 3 factors of x in the numerator. Okay? Likewise for the y's. 3 factors of y in the numerator, 7 in the denominator, leaves me with 3 canceling. 3 canceling out of this y to the 7th will leave me with y to the 4th. And you can see my final answer is the same as what I had before. 5x to the 3rd over 3y to the 4th. So that's how you handle it when it's monomials. That's probably a faster way. Now when you get to binomials and trinomials, we have to be careful. We cannot start canceling right away like we did up here. What you have to look at are the factors, which means, bottom line, you have to factor both numerator and denominator in order to see what the common factors are before you can cancel. What people want to do is just jump right in. Well, that x cancels with that x. No, it doesn't, because x is not a factor of the numerator, and x is not a factor of the denominator. Yeah, I see the x right there just as you do, but it's not a factor. They need to be factors before you can cancel. If we're not talking common factors, it would be like me up here saying, well, let's cancel 8 and 6. You know that would be crazy to do that. You can't do those sort of things with numbers. Well, it's really no different if you start canceling x's right here. So until you factor these, you are not canceling anything. So this goes back to our factoring skills. The numerator, the greatest common factor is 10. We always start there. We're left with x minus 3 when we factor. Now I can see what the factors of the numerator are. The denominator, we'll factor that, unfoil it, how I do that, which would be x minus 3, x minus 2. Multiplies to be positive 6, adds to be negative 5. And now we can clearly see what are the common factors. Well, clearly, the numerator and the denominator both have a common factor of x minus 3. We cancel that out, and we write our final answer as 10 in the numerator, x minus 2 in the denominator. And that's what we call simplifying a rational expression. All right. Take a look at this one. It's the same game, just a little bit bigger with the factoring. First thing I'm doing is factoring out the GCF in the numerator, which is 3x. We're left with x squared minus x minus 20. Denominator, factor out of 6x, we're left with x plus 4. All right, now, if you notice in the numerator, that x squared minus x minus 20 factors further, so we'll go with 3x. That'll be x minus 5, x plus 4. Denominator does not factor any further, so 6x, x plus 4. And now we can see what the common factors are. You only cancel a monomial with another monomial. Don't ever cancel a monomial with a binomial. So if we had just 3x over 6x, you would say 1 over 2, 3 over 6. And notice the x's cancel outright. So we're just left with a 2 in the denominator. Now notice the x plus 4's also cancel, so you just have to take stock. What do I have left? Well, I have an x minus 5, and I have a 2. So the final answer, I'm writing x minus 5 over 2, and that's the simplified version of this rational expression. Okay, last one, I put a little asterisk by this. Just be careful. It's not that it's difficult, but we have to understand this concept. That is, factor before anything. So the numerator factors into x plus 8, x minus 5. Hopefully that's not off the screen there. No, we're good. Okay, the denominator is the difference of two squares. Now, careful, the 25's first, so it has to go 5 plus x, 5 minus x. Now, here's the issue. This is why I have a little asterisk by this. X minus 5 and 5 minus x are not the same. They're what we call opposites, right? Well, so what? What are opposites? Opposites are like 7 and a negative 7, a negative 5 and a positive 5, a 3 and a negative 3. Those are opposites. Now, if you had a situation where you had to simplify these, I would hope in every situation you would say that this is negative 1, negative 1, negative 1. And it is. A number divided by its opposite will always be negative 1. So, are we going to cancel x minus 5 and 5 minus x? The answer is yes, but there's going to be a negative 1 left over. So we would write our final answer. We'll put that negative right in front of the fraction, right in the middle. And then the numerator is x plus 8. The denominator is 5 plus x. And we'll call that our final answer. Right?